Okay, so we're now ready to introduce a new mathematical object. So last time we gave a big picture intuition of where we're going for the next month or so, month and a half. Okay? And that is, we want to look at being able to come up with the equation of a tangent line. And specifically, we're looking for the slope of a tangent line. And that involved this idea of bringing one point closer to another point. Okay? That idea of bringing something closer and closer to something else, and then looking at the results, is something that we haven't really worked with mathematically before. So we need to introduce a brand new mathematical object, and this will be called a limit. Okay? To be honest, we are not going to actually give the true definition tonight. Okay? The true definition of the limit is actually a pretty complicated one, and we will cover that in 2.7. Okay? But it's better, I found it's better to just give you a general definition, kind of a loose definition, and we'll get more precise later with that. Okay, so this is not the precise definition, okay, but it's good enough for what we're doing. Okay? So we say we've got a function. It's defined on some open interval around some point, some x value a. Now that a value may or may not be in the domain of the function. Okay? In a lot of instances, it will not be in the domain of the function. Okay? But the function's defined around that point in some open interval. Okay? Then we're going to say that the limit as x approaches a of f of x is equal to L if the following situation holds. We're going to say this if, as x gets closer and closer to a, f of x gets closer and closer to L. All right, so this is a math class. Math is like a foreign language. Okay, we can't just all look up and read it and write it. We should sometimes practice speaking it. So let's all talk some math together. This says the limit as x approaches a of f of x is L. All together, the limit as x approaches a of f of x is L. That was decent. That was decent. All right. There's oftentimes with math, there's multiple layers that you can read it at. Okay, that's the most basic layer to read it at. Literally saying what this says in math notation. Another way of interpreting it, though, is, remember, it is shorthand for this idea right here, saying as the domain values get close to A, the range values get close to L. I think if you interpret it that way, you get a lot more information. As the domain values get close to A, the range values get close to L, which is what this is saying right here, which is exactly what this is saying. Okay? Any questions on that? Let's say that. As the domain values get close to A, the range values get close to L. All together? As the domain values get close to A, the range values get close to L. Aren't we having fun? All right.